Alrighty. So much like we did with rational equations and expressions, we're going to do similar stuff. We're going to talk about operations with radicals, which again is square roots. And we're also going to talk about how to solve equations. So remember, solving means x equals a number. Once you get to that point, then you know that you're done, you've solved. Alright, so let's talk the how-tos. So, first things first, operations. Adding and subtracting radicals. I like to think of it just like you do with variables. So with variables, 4x plus 3x equals 7x. It's the same idea with radicals. If you have a 2 square roots of 3, a square root of 2, and a negative 4 square roots of 3, you can only combine radicands with the same. So you add or subtract coefficients, just like you do with the variables, but you can only do it when they have the same variable, the same thing connected. So even though it's not a variable, it's a radicand, you can still only combine the ones that are alike. So the 2 square roots of 3 can only be combined with the negative 4 square roots of 3. And the square root of 2 kind of just hangs out on its own. It's in a whole different language there. Alright, so a positive 2 and a... Alrighty, multiplication. It's not so bad. I would say that probably addition and subtraction is easier, but this definitely is not anywhere near any of the hardest stuff that you've ever learned. Okay? You just need to remember the things that you've already learned. Distributive and FOIL. Those same things apply. You just have to remember to use your head and try them out. So distributive, I like to do, when I multiply, I like to do it in an order. The first thing that I do is I multiply the numbers. Just regular old numbers. If there isn't a number in front of a square root, it's just multiplied by 1. The second thing I like to do is to multiply the square roots, and then you're done. Remembering that something like the square root of 2 times the square root of 2 is just 2. Alright, so let's try it out. We're going to try it right here. Remembering to distribute, we've got 3 times that invisible 1 in front, which is 3. And then we multiply the square roots. So we've got square root of 2 times square root of 2, which is just 2. And since everything was multiplied before, you keep the multiplication between things here. Now we've got a plus, and we distribute it. Okay, we've got 3 times 4, 12. And then we've got the square root of 2 times the square root of 6. Remembering that you multiply under the square root of 12. 3 times 2 is 6 plus 12. Square roots of 12 is 4 times 3. So it's really 6 plus 2 times 12, square roots of 3, which is 6 plus 24 square roots of 3. There we go. Now this next one looks very, very similar. Different numbers, same idea though, so if you want to try this one on your own, please do. You're going to do the same thing, distribute that over. Alright, so 2 times our invisible 1 is 2. Square root of 3 times square root of 2 is the square root of 6. Plus 2 times 3 is, or 2 times 5 is 10. Square root of 3 times the square root of 6 is the square root of 18. The square root of 6 can't be simplified. It's not divisible by any perfect square. And 10 square roots of 18 can, though. 9 times 2 will give you that 18. Okay, so we've got 2 square roots of 6 plus 3 times 10 square roots of 2 which is that 2 square roots of 6 plus 3 times 10 is 30 square roots of 2. There's your final answer. Okay. Now we've got to do FOIL. So if you feel comfortable trying it, please do. You can always check your answers. 3 plus 2 square roots of 2. Remembering that when you have a squared here, that you have to multiply it by itself. Now we have to FOIL. First times first. 3 times 3 is 9. Outers. 3 times 2 is 6, square roots of 2. Okay. Inners. 2 times 3 is 6, square roots of 2. And lasts. So 2 times 2 is 4. Square root of 2 times the square root of 2 is 2. Alright, so we've got a 9. A 6 square roots of 2 and a 6 square roots of 2 makes 12 square roots of 2. Plus 4 times 2 is 8. That 8 and the 9 can be combined to 17 plus 12 square roots of 2. There you go. Next one. If you are ready to try it, again, please do go for it. I'm going to rewrite this so that I know for sure I'm going to be foiling it out. Alright, firsts. 3 times 3 is 9. Square root of 8 times the square root of 8 is 8. Outers. 3 times a negative 5 is negative 15. Square roots of 8. Inners. Negative 5 times 3 is a negative 15 square roots of 8. And negative 5 times negative 5 is a positive 25. 9 times 8 is 72. 15 and a 15, both negative, gives you a negative 30 square roots of 8 plus 25. Okay, 72 and 25 will give you 97. Minus 30 square roots of 8, which is 4 times 2. So it's 97 minus 30 times 2 square roots of 2. Which if you multiply that, 97 minus 60 square roots of 2. There you go. One more. The only difference between this one and the ones that we've been doing before is that these ones were just squared, so it's multiplied by itself. You've got the same two things being multiplied. So you end up with those same two middle terms. Whereas this one, you've got two completely different things being multiplied. But it's the same process. So first times first, square root of 2 times 1, square root of 2. Outers, square root of 2 times negative 5 square roots of 2. I've got that invisible 1 times negative 5 is negative 5. And the square root of 2 times the square root of 2 is 2. Now my inners, 4 times 1 is 4, plus 4 times negative 5 is negative 20 square roots of 2. Alright, so now I've got a positive square root of 2 and a negative 20 square roots of 2, negative 19 square roots of 2, and I've got a negative 10 and a positive 4, which gives me a negative 6. There we go. Wham bam. Alright. So now that you know how to work with some of the different operations with radicals, we're going to see if you can use that to solve. So your first step is to isolate the radical. So get it all by itself. Alright? So we're going to do that with this problem right here. Okay, so get the radical by itself. So we want this by itself. Everything else on this side needs to move, which is that positive 1. Square root of 2x plus 1 equals, if we subtract 1 from both sides, 3. Now, you guys know how to get rid of these radicals. Square both sides. So I'm going to squared and a squared. So I end up with 2x plus 1 equals 3 squared, which is 9. Now we just solve for the variable. Subtract 1, we get 8 equals 2x, divide by 2, we get x equals 4. Alright, and if you have a quadratic, so if you have something that ends up looking like x squared plus something x plus c, ax squared plus bx plus c, something that looks like that, then you need to factor or use one of your other methods to solve for x. The most important thing to remember is to check your answers with this. When you square both sides, you could get answers that truly are not true. So let's try it. Our original was the square root of 2 times x plus 1. Then there was a plus 1 outside of the radical equals 4. 2 times 4 is 8 plus 1 is 9. Square root of 9 plus 1 equals 4. Square root of 9 is 3 plus 1 equals 4. Alright, we end up with a 4 on both sides. So we are true. Yay. Alright, now we're going to try it. So we've got a couple to try. Start at the beginning. First things first, isolate your variable, or your radical. So, get that square root of x by itself. We're going to add 8 to both sides. Square root of x equals 8. Squared both sides. So we get x equals 64. Now we have to check it. So we had the square root of x minus 8 equals 0. Square root of 64 is 8 minus 8 equals 0. So we have 0 equals 0. Smiley face. Awesome, it worked. Next one. Get that radical by itself. So we've got the square root of 2x equals negative 4. We're going to square both sides, so that negative is going to go away. So we've got 2x equals 4 squared, which is 16. And if we divide by 2 on both sides, we get x equals 8. Alright, let's check it. We had the square root of 2 times our x plus 4 equals 0. So we've got 2 times 8 under the square root there, so that's square root of 16 plus 4 equals 0. Square root of 16 is 4, plus 4 equals 0. We have 8 equals 0. Not true. So, this is not an answer. Okay, in a case like that, you can go ahead and just say that x equals 8 is not a solution. You would have to have a little bit more information to be able to say that there is no solution at all. But you know that x equals 8 is not a solution. Alright, let's talk through this last one. We've got the square root of 4x plus 1 equals 7. If you look, that square root is all by itself already. Perfect. Then you can skip right to the step where you squared both sides. 4x plus 1 equals 49. Get that x by itself, so we're going to subtract 1. 48 equals 4x. We're going to divide by 4, x equals 12. Now we check. So the square root of 4 times my x plus 1 equals 7. Let's see. 4 times 12 is 48, plus 1. Square root of 49 is 7, so we get 7 equals 7, 7 on both sides. Yay. That one did work out. Okay. Your homework's going to have some of these and some where you just do the operation. Remember that if it says to solve, you need x to equal a number. That's the only big thing that I can really remind you of, other than the fact that you really, really, really need to remember to check your answers. That is one of the most important things you can do in this section. Alright? Other than that, you can start the homework. And good luck. If you have any questions, let me know.